The things I love about Google Cloud Platform is scalability, fault tolerance, and performance.
Performance.
Attention.
BigQuery.
The scaling ability.
We've been able to scale from thousands of users to millions of users.
It allowed us to focus on our product, and we grew really fast.
Because of the Google Cloud Platform, we could make investments in our product first as opposed to infrastructure. And so we could iterate really quick on building the right product.
The things I love about
Hi everyone, welcome to day 4 of the HackFest 2022. Today is the commencement of a second of the 4 workshops planned as part of the learner track at HackFest 2022. Today we will be joined by distinguished speakers from the Google developers who will be sharing their invaluable knowledge and experience in the Google Cloud. Hi, so let me start by introducing myself. My name is Alina. I'm a tech team member at Google Developer Student Club in NTU, and I'm a year 2 computer science major. Okay. So I shall be reading the notice of recording for everyone present. So this virtual event will be recorded for student activity and promotional purposes. By entering the session, you consent to have photos/videos taken of you and your work. So let me talk about the agenda for today's session. We will start by introducing our speakers, followed by sessions by both of our keynote speakers. We will wrap it up with a Q&A for 25 minutes, followed by a wrap-up session. Thank you. So now introducing to you our speakers for the event, Mr. Haizwa and Mr. Waywan. The first sharing session will be conducted by Mr. Harizwan. So let me introduce our distinguished speaker. He is a developer engineer at Acronis. He's an avid fan of tools and technologies and has dabbed in various programming languages such as Golang, Python, and R. He's currently one of the co-organizers for the GDG Cloud Singapore Meetup Group. So Mr. Hazwan, I shall pass my time on to you, please. Thank you.
All right. I believe that my screen is shared. Someone can just confirm that with me.
Yes.
All right. Okay. So I'm going to keep this pretty short because essentially, Google Cloud is a pretty massive platform. No way can I cover everything that you need to know with regards to the platform. And even then, yeah, whatever is covered today, maybe by the end of this year, maybe certain things will be deprecated, new features will be added. So so essentially this is kind of like almost like a crash course in a sense of what is available in Google Cloud. That doesn't mean like you go through this thing and like you instantly know. At the end of the day, it's best to actually experience the platform by actually going into by logging in and actually like tinkering around with all the products and features that is provided by the platform. So let me open this slideshow. Okay. So a quick kind of intro about me. Just now I was introduced as software engineer, but yeah, I kind of moved on to DevOps engineer. So now currently a DevOps engineer at Acronis, kind of doing a lot of Kubernetes, a lot of stuff surrounding Kubernetes, essentially supporting application teams in getting their applications to be deployed onto Kubernetes clusters, etc. And as well, it was mentioned that I'm one of the co-organizers of GDG Cloud Singapore. I think the next speaker is also a co-organizer as well. So yeah. Okay, so first thing, so let's jump right in quickly. Like what kind of services can you expect in Google Cloud? So as I was mentioning, there are a lot of services. It's very hard to kind of cover like everything in detail, but I guess in a nutshell, for a developer, and like one where we have to go and quickly get something up and running pretty quickly. These are the set of services that you kind of want to look at and be interested to quickly explore. Definitely best to check out the documentation to see how they work in detail. So there are multiple categories. So let's go from left to right. So the first one on the left is the compute services that's available on Google Cloud. Later when I switch over to the actual platform, you'll see that things have been rearranged. So like these screenshots are already kind of like, this screenshot was taken last year and it's already like outdated already. So that's why I was saying like there's no point of like just going through it once. You have to keep like continuously keep yourself updated. But the services are still around. So the first one for compute, there's this thing called App Engine. App Engine is kind of a super managed version of deploying web applications to Google Cloud. This is like one of the OG kind of services. I've rarely heard people use this one. If they are those who have been on Google Cloud for a long time and they are like fans of this product. This product definitely has its fan base because of the ease of getting web applications up and running and scalability. But it is but basically when you use this product, this App Engine product, essentially you're tied to Google Cloud. Other cloud platforms don't provide it, like AWS and Azure. There's no such thing as App Engine there. They have their alternatives, but App Engine is only specific to Google Cloud. Then the next one on the compute list is Compute Engine. Compute Engine is just plain old VM. Like if you know how to spin up a VM on your own local computer, essentially Compute Engine is just Google provides you a VM. Okay, Kubernetes Engine is essentially, if you are familiar with the world of containers, this is a platform that manages that. If you're not that familiar, then I best to get started with containers. Later, I'll be doing a demo on how you can use containers. I won't be using Kubernetes Engine in the demo. I'll be using another service called Cloud Run. But yeah, I'll go and once at a time. So next one is Cloud Functions. Cloud Functions, as it says, you write a function, you pass it to Google Cloud, and you basically tell Google Cloud like, hey, Google Cloud, run this as a web application. Cloud Run is you pass a container to Google, and Google will run that container for you. So they are doing the same thing. So they take your code in whatever shape or form. Like if you encapsulate your code in a container, you can use certain services like Cloud Run, Kubernetes Engine, etc. And all their purpose is just to expose some sort of endpoint which you can then contact. So that's for the compute side. VMware Engine is the expensive product, so you probably wouldn't want to even explore that. So next is storage. Storage, the main product that will be generally useful with cloud storage. Cloud storage, if you are familiar with Amazon AWS, is similar to AWS S3. So essentially, if you have large objects that you need to store, that's kind of where you store it, because like storing it on disk is actually pretty on the expensive side. So cloud storage is kind of like, in a sense, infinite storage. Yeah, I've never heard of someone being stopped and like told not to store any more objects on cloud storage. Essentially, the only limiting factor is your budget. So yeah. And then the last one is just databases. So these are all the different kind of databases that is provided by Google Cloud. So there's a mixture of NoSQL and SQL. So for those who are not familiar, SQL is essentially is a relational database. You need to kind of define a set schema of how your data is to be represented, and the data is to be stored in such a way. And then there's no SQL where you don't need to define a schema. Essentially, the thing is almost stored like a JSON blob. Stored in like one JSON blob, one row, one JSON blob, one row. It helps in certain types of applications, but yeah, it all boils down to what kind of applications that you are trying to develop. So certain applications you kind of need a more relational database, like maybe this Cloud SQL, or sometimes like structure doesn't matter. Maybe like let's say you're trying to do a chat app, and maybe chat app all you need, or you're defining like a text and some multiple fields. That might be a best use case for NoSQL. So maybe you can put in some NoSQL databases like Bigtable or Datastore. Yeah. So if anyone has any questions, I'm not sure how questions are going to be handled, but I guess can be highlighted in some way. But yeah, if anyone has any questions, just comment or something, or do something to get the host's attention.
Oh no, yes. I think so. The questions will be after the session, so you continue, please.
Oh, okay. That's good. That's good. All right. So okay, so the next few slides is kind of like a kind of repeat of what I was just kind of mentioning. So there's the compute options, yeah. Then okay, so let's go straight to demo for compute, which is going to be the most essential part, especially if you are in a hackathon kind of environment. You kind of what you kind of want is something that you can quickly get up and running. So I have a code base that if you want, you can kind of utilize and experiment with as well. So this like essentially is a code base where I do all my experimental Golang applications. So yeah, as mentioned before, I was previously a software engineer. So I'm mostly writing a lot of Golang. So basically over here is a lot of sample applications that you can try out. So the sample applications that I'm going to try to deploy to quickly demo some of the functions in Google Cloud Platform is just a basic web application. If you are not familiar with Golang, it should be simple enough such that you can quickly look at the functionality. It's like, okay, this is what it does. So all it does is just expose one single endpoint on the root URL. So handle func one root URL is exposed on port 8080. And that's basically it. And then basically all it does is it returns a response. This is a test. Hello world. Hello world. Meowza. Yeah. So that's basically it. So I'm going to quickly demo the functionality of this. So first, we're going to try to test it locally, to demonstrate that it's actually working before we go to the next steps. So first things first, we are going to try to run this application. Oh, hold on, wrong directory. We need to go into the basic folder. Is this big enough? Oh, okay. Hopefully this is big enough. Okay, so let's try to run this to make sure that it's working fine. Okay, so I started the Golang application. I'm going to open another terminal. We're going to use a command called curl. Curl basically what you can use to test out that application works fine. Application is running locally, so we'll contact via localhost. And then it's exposed on port 8080 as mentioned in the code base, and there's only one endpoint, which is the root. So hold on. Oh, okay, sorry. That wasn't the right app. Sorry. It was basic web. Hold on. It was on the basic web. So let me show. Okay, this is a Meowza. Okay, so let's run this instead. Okay, it's running on port 8080, curl localhost 8080. Okay, so we have the thing running fine. It's running fine on local. Okay, so let's say, let's go back to these slides. And then as mentioned here, the first demo is trying to run it on Google VM. So how do you get it running? So because this, you're trying to like hack this out quite quickly. So what you want to do is like kind of get something up and running pretty quickly. So the first thing is when you create a VM, we'll just clone the code into it. Generally, this kind of bad practice to kind of git clone a repo into a code base. What we want is artifacts within the virtual machine into the running instance. But for a hackathon kind of use cases, it should be fine. Because we're gonna eventually run it as a container, I'm gonna choose a different OS. So over here, the default OS is Debian. So what we're gonna do is we're gonna change it to something that has Docker within it. So let's see. There's this thing called Container Optimized OS. So basically, once you have that, essentially it automatically comes with Docker installed. So if you don't want to run the application in Docker, you can get a normal Debian, install your runtime. I'm not sure what runtime you are all familiar with. Maybe if you're using Python, you need to install Python within it, or etc. I won't go through how to install it because, you know, there are so many runtimes out there. So kind of hard to kind of cover all of them. So we're gonna container OS. So it comes with Docker. The important thing is we'll need to click on this checkbox. So it's a HTTP traffic. If you don't tick this, essentially you will never be able to access it from outside. Which in this case, that's what we want. So with that, we can quickly create a VM. Okay, then we'll wait for it to start up. Google VMs generally start up pretty quickly, at least within 2 minutes, 3 minutes at most. So far, I haven't like seen it like take a long time. Okay, so it's up. Let's click on SSH. Basically, you can skip the whole step of like trying to figure out how do I SSH in, how to get keys, whatever. You can just click on the SSH button. It brings you to another window where you can manipulate with the virtual machine and do what you need. Yes.
That's convenient.
Yes. I believe in Amazon, you need to kind of figure out keys, etc. So yeah, that's a bit on the harder side.
Yeah.
Let me see. Hopefully this is big enough. Okay, so what we're going to do is check that Git is installed, Docker is installed. Yeah, so you can see that both command lines are available. What I'm going to do is clone this repo. Clone the repo in. Okay, once you clone the repo in, then we just go into it and find the piece of code that was mentioned just now, which is under web and then under basic web. Oh, cd basic web. Okay, just to check that the application is really that. So as you see, hello world Mailza. Next part, because I don't exactly have Go in this instance, so if we try to check Go, it's like Go is not found. I'm gonna instead run the application in a container instead. So that's kind of more generic in a sense. So to use Docker, the main command is kind of like docker build -t. So -t, if you see the docker build command, -t is essentially what we want to name the image that is being built. So with docker build -t, in this case, let's do a very short form. And then after that, then we need to define where which folder to kind of build it from.
Okay. Oh.
Yeah, so the file that we kind of need here is, if I'm not wrong, let me go back here. Whenever we build a Docker image, there's one main file that we need, which is a Docker file. You can have multiple Docker files, but once you have like Docker file, that is like the default file that the Docker command kind of look for. So in this case, the Docker command essentially is saying that first get a Docker image that contains the Golang runtime of version 1.14. Yeah, this is a pretty old code base. Add all the code within this folder, and then after that, run the command to build the application, and then make sure that this container is exposed on port 8080. There's the fourth line, and then the last line is essentially when you start up, what command do you wish to run? So because we built our Go application into app binary, so we'll just say run the app binary. So that's essentially what this Docker command is kind of saying. So with this, we have a Docker image. We can then run this pretty quickly. So we have the image. The image name is called lol. We run it with -d like daemon mode or some sort. The important part is what ports we wish to expose, because when you run a container, by default, it's not available to be accessed from the host machine, nor is it available for access from outside. So basically, you say to the Docker runtime side, okay, for this container, I want you to expose port 8080 of the container to port 8080 of this current host machine. So that's what we want here. So in this case, we'll put this Docker run -d is daemon mode, -p is which port to expose, port 8080 to port 8080 of current machine to port 8080 of container, and then the image name. So with that, basically because demo mode, right? So it's like runs the command and immediately exits the command. But when you can see, if you run Docker ps-a, you can see that the Docker container is running. If you want to look at the logs for this, can Docker logs this, then you'll see that these are log sets available from this container. So if you want to ping it of sort, or like access the endpoint, so just curl localhost port 8080, and there you go. But the thing is, at the end of the day, what we want is we want this to be exposed to the outside world, or basically, let's say if you have a front end on your local computer, but your backend is on this server. So how do you access it in that sense?
Yeah.
So let's shut down that image just now, so we can Docker stop that image. Not that image, that running container. We need to remove it for now because we don't want it to. Because like when a container that is exposed on a certain port is running, basically that port is kind of blocked for the whole VM. So if you want to make sure that we are not affecting the runtime of other containers that we want to start up, it's best to make sure that your environment is kind of clear. So we'll check no containers running. So instead of running it and exposing it on port 8080, let's expose it on port 80.
Okay. So there's a question in the chat.
Yes.
Yeah. It says, is it possible to RDP instead of SSH, just so we can use GUI instead of CLI?
Okay. So technically is so for RDP, I believe it's more for Windows environment. I've rarely seen RDP for Linux environment. I believe the option is there, but personally, I've never used it before. I think that functionality is there, but I've never used it before. So yeah, because like most of this stuff, especially if you go online, right? When it comes to how do I run the container and everything. Most of the stuff is available in command line. And if you are working in the in the software engineering space, especially for the bigger companies, most of them just mainly use command line. There are instances where they use GUI, but yeah, those GUI is mostly for your own local environment. The moment you jump onto the server, essentially GUI becomes expense. It takes certain complete cycles to render a GUI and all. Okay, so hopefully that answers that question. Let's continue. So with that, now we have localhost 80. So you'll see that we use a different port. So now we are saying that we want our port 8080 of a container to be exposed on port 80 of our current virtual machine. And port 80 is the normal for HTTP port. So it's like if you any website you go, actually it's using the default port of port 80. So you just curl localhost, it should return that response. Now the important thing is how do you access it from outside? So you see over here there's two IPs, internal IP and external IP. Internal IP is, let's say if you have two instances, you want them to talk to each other, that is the IP that you'll be using. External IP is the one that we'll need to use to access it. So you copy that external IP, you go to your own like terminal, and then you just curl that IP. And because it's exposed on port 80, it is, you just kind of need to just do that. And there you go. So that is accessing a website that's deployed via container in a virtual machine. How much time do I have left? Do I have enough time?
I think we have some time. Yeah, you go ahead, please.
Okay. Because I got one more demo that I feel like it might be also useful. Okay, so just now it was deploying a container to a virtual machine and exposing it, and that's how you can get kind of one running application which you can access via your front end. I'm not sure what front end you might be using.
Okay.
Next one would be on another thing, which should be more simpler because more GUI based. We kind of do almost the same thing here, which is docker build -t on local machine. We'll need to build an image first, because the next demo will be to deploy it on this service called Google Cloud Run. And I was mentioning just now, Google Cloud Run essentially is you build a container, you pass the container to Google Cloud, and you tell Google Cloud, hey, Google Cloud, please run this container for me. And then Google Cloud will handle the running of the application and the scaling of the application and whatsoever. So let's quickly build this. The first things first is, actually this might not be the best place for me to demonstrate this because there might be authorization issues.
Okay.
Yeah, that's the main issue.
Fair
If
enough.
you want to do it on local, you need to like authorize your Docker to be able to talk to Google Cloud. So I'm going to show another method which should be easier, hopefully. For those who want to build the container, pass it, and use Google Cloud Run. So first things first, we'll need to clone our repo. Let's clone the repo. Okay. Okay, so one the repo is clone. We'll go into the repo. We'll build the same application. So it's under web and then under basic web. Let me clear this, and then then we'll need to build the container. If not, yes, it should be asking for permission. You just authorize it. This is the authorization part. This is the part where you might find some issues with it on your own local machine. So if you're using it from Cloud Shell, it's easier. So the Cloud Shell command was that to trigger this is all here, this little button here. So yeah, it's building the image. Essentially, this Cloud Shell essentially is temporary virtual machine that Google Cloud provisioned for you, and inside it, it contains almost every command you can think of. If you want to connect to Kubernetes, it's all here. There are various, like, I believe Go is also here as well. Go, yes, Go is also here. I think Python is here. Almost a lot of the programming languages is here. It's like a dev environment virtual machine. Everything is all loaded in. Okay.
That's nice. Yeah.
So just now we already built our image. Next bit is to try to run it. So let's try to run it via port 8080, 8080, and then we'll try to run it. So you'll see that the image is running. To try it out, there's this web preview mode. Just click on the web preview, and then you can preview it on port 8080 because we expose it on port 8080. Okay, and then as you can see here, it's a temporary virtual machine, and then this is the text. It's the same text. Like there's no changes. So how do we use Google Cloud Run? Google Cloud Run, essentially what we need to do is have the container in this like big repo called container registry. So it stores all the container that you wish to use. So we need to send our container there first before we are able to tell Cloud Run to use it. So to send the image to container registry, first what we need to do is we need to tag our build image just now with a special tag. Like we need to follow this certain format. So GCRIO project ID, the space, we need to make sure that there's no space there. In this case, I kind of want it to be the name of the application to be Hello World, and I want it to be version 4 now. So once we tag it, it actually doing nothing, just relabeling the built image, and then we'll just push. Let's push. So this push command essentially is the one that actually push the image to this product called Google Container Registry. Google Container Registry contains all the containers that you wish to use within the cloud platform. So there's this product called Container Registry. You click on it, you'll see a whole bunch of images. Like this is kind of my own test bed of sorts. So just now, as I was saying, Hello World v4, right? So let's find Hello World. So Hello World, yes, here. And then if you click on it, there should be a v4 here. So v4, it was pushed 2 minutes ago. So this is our container, and this is the image that we are gonna kind of run. So let's go to Cloud Run. Then after that, we just create service. And then in Cloud Run, what we need to do first, decide what container we wish to run. So just now I was mentioning, we're gonna run the Hello World v4. So we just find Hello World v4, select. We'll call this app Hello World. We let it be the default US Central because this is just an example. To make sure that I'm not built too heavily, I make sure that maximum number of instances is 1 so that in Google Cloud don't go crazy. You're gonna allow all traffic, and then this is the kind of important bit, is whether to authenticate that request or not. So by default, it should be require authentication if you want anybody in the world to kind of access it. Let's say if you are trying to create some sort of API of sorts, and you want like any front end to access it, what you want is unauthenticated invocations. Yes. So this is the kind of important bit. Other things that you kind of want to take note is make sure that our application is exposed on port 8080. This is what we want to access. Memory, CPU, timeout is sufficient. If you are using a Java application, you might need more time. Or let's say if you're using something like Python, and if Python, if you don't include some bells and whistles, it can only handle like very few requests at one time. So you might want to take note of that. So this is where you kind of configure those kind of stuff. Yeah, so this kind of all the other configurations, then we just create. So once we click on create, what Google Cloud Run will then do is it will fetch the image and it will create a special URL for you where you can then access this endpoint. The endpoint is all accessed via port 80. So it's like it's mapping port 8080 to port 80. So this is the URL. You copy and then you paste it. And there you go. So this is kind of how you do it. So this is more UI based, yes.
All right.
So it should be more simpler. I believe I kind of almost
yeah. No, it's fine. You can share if there's anything else important you would like to say before we move on to the next speaker.
Okay, so so I kind of going to start wrapping up already. So just one important thing is if you're trying to build backends on Google Cloud Platform and if you're using a modern front end, be aware of cost. Cost will bite you really hard if you're using SPA. So I can't go too deep into this because you know, there's a lot of details to kind of go through. These are just the kind of things that you might want to check and research on. Yes. Database, storage, big data. Big data options, if you are interested, if you are like, you know, if your little project kind of requires you to process massive amount of data, you can look at these products. You can use BigQuery, load the data into BigQuery, and then use some SQL to kind of transverse your terabytes of data. So in terms of big data options, that's the main one that you want to gun for. Machine learning options, there are various machine learning products that Google Cloud has. So there's speech to text, text to speech, there is vision. So you want to like detect how many cars are there in the picture. It's all there. There's this thing called document AI and video intelligence. So you can try to explore those products to see if they are useful for your project. I kind of want to talk about this, but I guess maybe next time. So I think this is another important bit. So how do you try to start using this for free? So for Cloud Run, I'm not sure how many seconds of invocation that you can use, but Cloud Run is pretty cheap if you're doing a sample project. So if I'm not wrong, I have a Cloud Run instance running for quite a while. I've been built only like 3-4 cents till now, and it has been running for like months already. So 3-4 cents across months, that's pretty cheap. So the reason why Cloud Run is I'm recommending Cloud Run here, especially for sample projects, is because you are only built on its invocation. That means when you access that endpoint, then that instance starts up for that Cloud Run to serve you that traffic, then you're built for that amount of seconds. As compared to a virtual machine, the moment you switch it on, you are built from that hour onwards. Even if no one is accessing the machine or no one is accessing the endpoint, you are still built. So even if no one is using it, you're still built on it. As compared to Cloud Run, you are only built if outsider is accessing your endpoint. So yeah, or you can like look at all these free tier, access the endpoint, access that URL, and see if there are products that you want to try for this hackathon. If you are interested in more advice, you know, and find like some sort of cheat sheet on what the product does, etc., you can go to that link there. If you are interested to reach out to other people who are using Google Cloud Platform, you can try to join that Slack group. I believe the link should still be valid. But if the link is not valid, just reach out to the Facebook group. Just post your question there. People should respond pretty within the week. Yeah. So yeah, that's it.
Wow. Thank you so much, Mr. Hazwan, for the insightful sharing session. I'm sure our participants had numerous takeaways from this, and thank you for sharing all the advice and the demos to illustrate it better. Now we will move on to the second speaker for today, Mr. Rian. Hi.
Hello.
So,
Share my screen first.
yeah. So let me introduce you first.
Oh, okay.
No. Go ahead. So you are currently the Director of Engineering at Zildon. As an engineer, you have worked with full stack development of scalable and distributed web applications. And you also develop as a software engineer for Archipelago Rocks, a classroom tool for teachers to better facilitate teaching for teachers and learning for students. And it's also used for NUS and like free to use, which is really great. Okay, so you may continue.
Does this work? Is the screen?
Yeah.
Awesome. Thanks. Thanks for the intro as well.
Oh,
So yeah, very happy to be here to be speaking with all of you and also sharing on my topic today, case studies with Google Cloud. This is essentially two case studies I've worked on over the last year, and I'm sharing with you how we got this working in Google Cloud, and hopefully you will inspire or create some ideas on how or what things you're going to use in Google Cloud for a hackathon. So yeah, also just now, very great lead in from Harizwan. I think some of the topics are overlapping, and hopefully you will see like certain things that you mentioned about being used over here in my case study. So yeah, let's get started. Okay, so just want to start off the entire sharing with this image over here. I think this is probably something that most of you will not get to see, even if you get out, go to a working world in the future, like any companies, maybe you will get to see it if you go to a very old company. But data centers like this with hardware server racks and running aircon 24 hours, you're not going to see it most of the time. And definitely not something like this as well. People praying to machines and hoping that things don't break. This does happen during, previously when people are deploying new applications. But there's a more important underlying message here, which is that if you're as programmers, when we write code, when we run code, things are deterministic. But for machines, for hardware, things are not exactly deterministic. Things can break. Machines can break over time. Wear and tear can occur. And this is essentially the cost that comes along with running your own data center. And in today's world, most of us don't do that. We turn to cloud providers to get them to run this infrastructure for us. They can do it at a much more larger scale, getting economies of scale where they can charge us at much more lower cost. So we get this infrastructure, we lease this infrastructure from the cloud providers at a much more lower cost. And moving on from there, now this is like more of like 10 years ago, getting infrastructure from cloud provider. In today's world, the cloud provider is a very different world. It's not just a place of getting infrastructure. You're talking about service provider now. Just now, Harizwan mentioned about multitude of different services. If you take a look at this cheat sheet for Google Cloud, you can see there's so many different things that they do. Okay, but one issue comes along with this, nowadays where people, when I'm talking to people, they're asking, what exactly should I use in Google Cloud? There's so many things. And the important thing to note here is the distinction that you don't have to use everything. Just use what you need to solve for your problem. Okay, so it's overwhelming. Just use the things that you need, like some of the recommendations that Harizwan mentioned earlier on. Okay, so I'm going to use my case study to show you what tools you can identify for certain things to solve for an idea that you have. In this case, the problem we're trying to solve. In this case, we're trying to solve for a live streaming problem that we faced over the last few years. Okay, so I'll try and explain it with the problem statement. So essentially, as you all know, over the last 2 years, there has been this global pandemic event that occurred. Well, it's still there. But of course, recently, physical events are sort of allowed now. But a year ago, 2 years ago, physical events were not allowed. So this means that as online organizers, right, or as event organizers, we need to turn towards online events or streaming tools to serve these online events in order to run, all these events that we want to do. So moving from physical to online, we needed a live streaming solution. But for this organization that I was volunteering for, we had a very interesting requirement. Well, the standard stuff are like, as a volunteer organization, we want something to be affordable. We don't want to pay too much. And also something that's easy to use, for the speakers, for the administrators, something that we can just boot up very quickly, use it for the talk, and then, close it down. That's it. Hopefully not as crazy to use. But we also had one special requirement. We wanted to be able to stream our stream like this one, right? to multiple destinations. So not just one YouTube channel, being able to stream to, let's say, a few YouTube channels and also like Facebook pages at the same time. Okay, because we're working with multiple partners at that point. Okay, so this is essentially the problem statement that we had. And of course, as an engineer, there's always that age-old adage of like, don't reinvent the wheel. If there are solutions out there, try to find a solution that you can solve. But that's the thing. We tried to look for it. We couldn't find a proper solution. This common solutions that we found, we couldn't really find one that solved our needs, getting it to be easy to use, affordable, and also being able to stream to multiple destinations. So that's where we started thinking, can we use something like Google Cloud to build on top of this current solution? Because we also don't want to rebuild the whole thing. That's like building a full product, like a company itself. What if we just build, let's say, a wrapper solution around one of these solutions and create something that solves our problem? Okay, so that's where we decided, okay, let's go with StreamYard. StreamYard itself, just to explain very quickly, is a tool that you can use to stream to multiple destinations. Okay, and also it's easy to use. But the problem there is the contradiction between the affordability as well as the ability to stream to more destinations, because you have to pay for a higher subscription tier to stream to more areas. Okay, so this means if we wanted to expand to more partners, we need to pay more. So that itself, not exactly affordable. Okay, but we found a way to get around that. What if we stream to a custom RTMP server in Google Cloud and then use that to stream to even more locations? So this way, we can allow ourselves to scale up, but keep our application, or rather our subscription on StreamYard, limited to the lowest amount, lowest cost. So thus allowing us to be able to move our entire problem statement that we mentioned earlier on. Okay, and also one further enhancement we did here was just to make sure, instead of just assuming that we're using StreamYard, build it generically, we can serve like, something like this, Zoom or Google Meet, or continue using StreamYard in the future as well. Okay, so this is the solutioning that we got from, very early on. Okay, but the details is the fun part. So how do we get around doing this? I like to demonstrate this by using a architecture diagram. Okay, so what I drawn here is just a simple representation of the problem statement. You have the source, you have multiple destinations, and we have a black box. So we know that this black box, we need to host some application in Google Cloud to allow us to do this multiplexing of the source stream to the destination. Okay, so if I'm talking about hosting application in Google Cloud, there's already this is about talking about compute solutions in Google Cloud itself. And of course, there are multiple solutions in there. There's serverless, there's infrastructure as a system, like just now as Harizwan shown you both of them, Cloud Run for serverless, virtual machine for infrastructure as a service. Okay, so what solution should I use to solve for my problem? Again, another engineering age-old adage, which is there's no exactly right or wrong. Well, for a lot of problems, there's no exact right or wrong solution most of the time. Usually it's about the one thing, which is trade-offs. You need to find out what exactly meet your needs. Serverless could be easier to maintain, but it's harder to customize. But if you get a virtual machine, you can do whatever thing you want to it, but it's harder to maintain because now you have taken over the managed role from Google Cloud, because for serverless, they are doing a lot of those turning of the knobs of that service for you, but now you have to do it yourself. Okay, so in our case, it was actually a very simple choice to make because we realized we needed that customizability. We needed to support RTMP, which is not supported in serverless. So for us, we knew that going for compute engine was the choice. We need to get a virtual machine to solve for our problem. All right, so let's change this architectural diagram a little. You can see on the bottom right-hand side over there, there's that compute engine logo. So I'm just going to, at the bottom of this page, I'm just going to add more and more tools just to show you, what different things within this ecosystem that we are using to show you, what tools you can use. Okay, so Blackbox has been replaced by a virtual machine. The important details of, or rather the details of this running this server, well, it's not really important, but just to let you know, we're running a Nginx server with an RTMP module. Again, for your hackathon, for your ideas, maybe you're running a Node server, a Java server, or anything else. Doesn't necessarily need to be something like this. Okay, but in my instance, this is what we need to solve our problem. Again, just a very quick look at the configuration. We're just using this RTMP module to do that multiplexing. Line 20 to 23 over here, you can see over here, this is just a templating, right, for allowing us to add in all the destinations to push the stream towards. Okay, so we're not going to jump into this because this is not the interesting part. This is not talking about Google Cloud. Okay, so let's jump back to our architecture diagram. We're running this on port 1935. Okay, so this is the port for RTMP. And if we're using Google Cloud, of course, if you want to harden our service, we want to make sure we only expose ports that we use for application. Okay, so if I'm not using the HTTPS port, like for 443 or that, I can just leave it closed, in case I'm exposing some internet application that's using that port. All right, so make sure you use something like some firewall rules through using cloud network to secure your service. Okay, and then what else can we do with this solution to make it more production grade? Okay, one question some of you might be asking now is, well, just now we saw the demonstration using compute engine, and you set it up. Sometimes you need to go in and install some stuff. In this case, I need to install an Nginx server. I need to pull maybe some code or configuration inside. So it might not be exactly the easiest to use. There's some authentication, some credentials required, some manual setup process. Maybe it'll take a couple of hours. Every time I set this up, I need to put in some time. And just now, actually, Harizan already showed the answer that I'm going to show, which is that you can use container optimized OS, where you can use a Docker image and deploy it to this virtual machine. So Docker images, or in this case, images, right, are mostly used for our serverless tools inside Google Cloud, like Cloud Run and App Engine. But you can also use the same thing for a virtual machine under this specialized configuration for this virtual machine. Okay, and yep, as shown earlier on, you just need to provide some sort of address as well as the tag to indicate this is the image that I built for my application with all the installed Nginx and node server, all those goodness. Put it inside and then just deploy it. So when you go to the virtual machine, everything is already deployed. So this is the same if you want to run this Docker image in a local environment for testing and you need to fix something. Essentially, you can build the same image and push it to production where you have this total parity of environment. So this shouldn't break as often as it is because of this parity that you have placed put in place. Okay, but one other thing, again, earlier on already mentioned by Harizwan, in terms of, since we're using Docker images, you want to think about where you want to save your images. So a solution in Google Cloud, you can go for something like container registry, or later on, I'll actually talk about a second one, which is artifact registry, which you can also use for storing images. Okay. Now, just now, Harizan built it manually. Now, for a demo, of course, we want to show it very quickly, like how you can do it. But one thing is this, if you want to build this in a production application, like let's say you go to a company in the future, you can't be asking an engineer to commit code every single time and then building the images manually and pushing it up to Google Cloud. You want to do some sort of automation. If I change a piece of code, can I trigger some sort of build process, automated build process, to be able to push this image automatically and maybe even automating the deployment in the future? Okay, so in Google Cloud, in its extensive ecosystem, there is a tool you can use over here. So this is called Cloud Build. In the bottom, you can see. You can use this to craft a CI/CD pipeline. Link it together with an entire infrastructure. Every time you change a piece of code on your, let's say for GitHub, you can set in some webhook to allow yourself to be able to know that, okay, a code has changed on a certain branch, an important branch, and I want to use that to trigger this build process to build a new Docker image that I can use to deploy to this virtual machine. Okay, so just to show you, this is part of a configuration of how you would use, like the configuration file to use in Cloud Build. Over here is just a very simple one. I've created 2 steps to run within this CI/CD process, installing some node modules and basically just running through the build process. Just now what you see, what Harizwan did, but in this case, it's automated. Okay, I don't have to do it manually. And on the right, you can see this is the execution outcome. So if everything passes, you get all green check marks. If something fails, let's say if you are, you're part of, you wrote some regression tests within your application, you run it, something fails, it will show you over here with a red cross mark, and it will tell you within the logs what's failed. So you can use that to debug and fix your application. Okay, so truly a very interesting tool and useful tool if you want to use it to implement a CI/CD pipeline for your projects. Okay, next, again, another thing that wasn't really covered was that if you look at this application so far, this application, well, we can have these different sources coming in from StreamYard or from Zoom, but how do we know that these sources are authenticated? They have to pass some sort of token in. So this token essentially is a secret that we need to deploy into this virtual machine. Similarly, if I need to stream this or multiplex this stream to my destinations, how do these different destinations know that I'm a trusted source? Again, there's some token that I need to implement within this virtual machine. So again, some form of secrets. So we need to implement some form of secrets or configuration within this virtual machine. Okay, but one of the things is that it's generally bad practice to bake your secrets into the image. Okay, so we mentioned about using a Docker image. You can definitely build an image within a local environment with those secrets and push it up. But what's going to happen here is that you're actually conflating access control for your image registry as well as for your secrets. Like for someone who have access to that image, maybe they're not supposed to have access to the secrets, but because they could download that image, they can open it and take the secrets and use it, abuse it for some other thing. So what you want to do is to separate your secrets and make sure that you don't put that secrets and your Docker image together. Rather, what you want to do is when you install this image, you deploy this image, pull the secrets at the point of deployment, and then use that to run the application. And we can achieve that in Google Cloud using Secret Manager. Okay, again, another tool I've placed over here. So using Secret Manager, you can pull the information, the secrets that you secure inside Secret Manager into your virtual machine, as we see in this case over here. Okay, so Secret Manager itself, you can think of it as a repository where you can put in multiple secrets, but it's more than that. It's a very interesting system where you can actually use it for version management. Okay, so you can see over here, I've created like over 10 versions of this secret for this particular secret alone. And you can actually leave multiple of those enabled if you want. Let's say if you have multiple applications sharing this one secret, and maybe an older application that hasn't been deprecated is using an older version, leave it at that. You don't have to destroy those secrets. But for security purposes, of course, once you have fully deprecated an older version, older application, you can choose to destroy it. All right. So for Secret Manager, very, very interesting tool. Again, you can use it for securing your secrets and for deploying within your application. Okay, now let's go back to the infrastructure diagram. One thing that some of you might be thinking right now, like, this is kind of like those cooking shows where I just show you a part of like that completed product, but I haven't really explained, one part of this, which is how do we allow only this virtual machine to be able to talk to Secret Manager? If this virtual machine, right, like it doesn't have any identity, it can talk to the Secret Manager. Can't just anyone talk to Secret Manager as well and steal my secrets? What can we do to prevent that? So the important topic here is access control. Again, another important topic to think about, in terms of security, where we're dealing with cloud applications, and in fact, any applications in general where you're deploying online. Okay, so for access control, as you see here, I've added in one more tool, which is Cloud IAM, as you see on the bottom over here. By using Cloud IAM, what I'm going to do is within this virtual machine, I will assign a service account to it. Okay, so it's similar to a user account, but this is used for a machine. Okay, and in this service account, I'll grant it the permissions to be able to talk to Secret Manager. And through that, I'm able to only isolate the access to Secret Manager and also for my secrets only to this virtual machine. And also, of course, for myself as an admin, I already have read and write access into Secret Manager. So no one else will have access to this application as well as the secrets. Okay, and we have completely decoupled the secrets away from our Docker images. Okay, so this is how you can build some form of access control for some of your tools, not just Secret Manager. In fact, for other tools, like for example, for image registry as well, if you only want to allow a certain application to have access to your private images, you can use IAM to achieve the same effect. Okay, what else can we do to add this application? Well, one important thing is if we want to build a production application, in this case, we want to use this to serve for production stream. What about backing it up? There is that instance or scenarios where, let's say, Facebook can go down, Twitch can go down. And in the scenario where we are not able to stream to those platforms, we want to be able to capture this video feed, maybe convert it to an MP4 file, save it somewhere so we can use it to upload to Facebook later when it's up. Let's say if it goes down. So can we do that in GCP? So you can do that, make use of another tool. Again, over here, we're using this tool called Cloud Storage. Okay, so it's an object storage, allowing you to be able to store your files into these buckets. Okay. Okay, so we have a process. Just earlier on, I mentioned about the node server. What it does is it will watch the stream, and once the stream is done, you will take the video feed that was captured, convert it to MP4, and pushed it to this cloud storage. So at the end of it, we'll get something like this. So in the cloud storage bucket, you'll get the folders and the files indicating, where the file has been uploaded. If I click download on the file itself, like downloading any file from the internet, in this case, it's an MP4 file. From my browser, you'll just open the native player and play the entire video directly from my browser. Okay, so you can do that for the same of, like, let's say if you are running a web application, deploying a CSS or JavaScript assets, you can deploy it to your storage bucket if you want to look at saving money and not serving it directly from, let's say, your serverless applications. Okay, let's go back to architecture diagram. We're almost at the end. Another question that some of you might be asking right now is, well, we have covered so many tools. Earlier on, we talked about making things easier with using a Docker image. Is it really easy now that I've added in so many tools? I have to manually configure all of them. Is it really easy again to set this up? It seems to be a bit hard. Can we use some DevOps knowledge to be able to simplify this? And yes, there is. You can use this thing called infrastructure as code, which is a methodology allowing you to use certain tools to be able to consider your infrastructure as configuration or code instead. So you create this configuration or code, commit it to a code repository, and use it repeatedly to set up your application. Okay, so the next time when, let's say you set it up for the first time, the second time when you have to do this again, all you need to do is just run that tool to be able to bring up everything you see in this screen. Okay, so in Google Cloud, there is a tool that you can use to do this, infrastructure as code, which is called Deployment Manager. So you can look into this if you want to look at quickly bringing up all your applications at once. All right, so this is part of the configuration. I'm not going to jump in deep into these details. You can look into the guides on how you can set up Deployment Manager. But essentially, you will set up things like your deployment configuration in the YAML files or Jinja files. And then you can just use that directly to do your deployments. Okay, but in this case, I've also, for our particular solution, I've added in an additional shell script for certain things that are not supported in Deployment Manager. For example, assignment of the roles, like just now I mentioned about being able to access Secret Manager. So I have a shell script to be able to just very simply create a service account and assign the roles to that service account. Okay, so I'll run this together with Deployment Manager. And what happens is that I just need to run one shell script and the entire infrastructure comes up. Okay, and I can run another shell script to bring everything down as well. So this will come in later into helping us keeping this entire application in an affordable state. And I'll explain why later. Okay, so we have gone through our entire application together, like a production grade application, all the way up to making it deploying very easily. Because earlier on, as mentioned in our problem statement, we want to create an easy solution for ourselves to use, not just for the speakers, but also, as a administrator, I want to make it easy for myself to set it up and down every single time. Of course, there's other qualification of our solution. We mentioned being able to stream to multiple destinations is solved by virtue of building this, which is, as you can see over here, we were able to run it in an actual live stream. And you can see over here, I actually opened five live streams at one point of time of, this is, by the way, this is 2 different Facebook pages and 3 different YouTube channels, okay, running off the same stream at the same time. Yeah. Okay. So we've managed to solve 2 qualities over here. What about the last quality, making it affordable? Okay, well, I haven't really talked about affordability. Of course, StreamYard, the lowest subscription, is not that expensive. But one thing that we need to talk about is the cost from Google Cloud, how much we're going to pay for it. So let me just show you. This is over a span of 6 months last year when we ran this program. And you can see that, of course, at the start, things were a little bit more pricey because we're still getting things started, smoothing the rough edges and making it a bit more streamlined. And by the end of it, we were able to find like just a minimum amount of things that we can run at the minimum amount of time. So by the end, for a 4 to 5 hours live stream, we were paying around, I would say, 80 cents. Okay, so in a month, we were running, let's say, like 2 live streams. That was just like $1-ish that we need to pay to get this ability, this live streaming solution that we want. Okay, and earlier on, remember I talked about Deployment Manager, being able to run a shell script to bring everything up and then run another script to bring it down. So this ties into this saving of or cost optimization, because what we can do is this, if I'm not using this live streaming solution, I can just bring it down. You can see over here, for the compute engine, we're paying the most for this. So if you're not using it, just bring it down. Most of the time we're not doing live streams anyway. We're just doing it, during this timing, like let's say 6 to 8 p.m. at night. Yeah. So this is how we were able to keep our costs quite low. And of course, there's also a lot of things you can see over here for billing, right? Over these 6 months, where it's actually $0. We're using Cloud Run. Well, I guess we're paying a bit for Secrets Manager. Oh yeah, Cloud Build as well. In this case, for our solution, we're using Cloud Build. But you can see we're not paying a single cent for it. And this is the same thing as what Harizwan mentioned just now. If you're falling under the free quota, you don't have to pay for a single cent. So if you're looking at running an application at zero cost, do make sure that you keep to that free quota. Don't exceed it, so that you won't have to pay a single cent for your solution. Okay, so we've gone through a lot of different tools within this one single case study. I want to talk about, this is actually, the sky's the limit. There's more things that we could have done here. This is a production grade application that we wanted to make it production grade. Well, we can't do it without telemetry. So monitoring is actually one of the things that we can actually add in to make it better. I think Harizwan also mentioned a bit about some of the ML tools. Of course, we could have used something like speech to text, speech API, essentially allowing us to convert the MP4 file into some text. So we can use it as subtitles and upload to our, let's say for YouTube, use as captions. So again, that's something that we could have used to improve our application even more. So it shows you that in GCP, as a service provider, you can use multiple services to make your application even better. Okay, so I think big question right now, I've shown you this case study, very complex example, but it might not apply entirely to you. So for yourself, you might be asking, I'm new to Google Cloud, or I want to build an idea here. Where exactly do I start? Okay, so I'm going to use a second, much more smaller case study, something I hacked over the last weekend, in order to show you, what you can actually build and what tools you might actually want to use if you are looking at, let's say, hosting a simple web application on Google Cloud. So the context of this is that I'm working with a professor in NUS, and he essentially wanted to explore into looking at using an open source project and hosting it in Google Cloud as a conference submission tool. Okay, so the actual application code is already there. All right, so let me show you a problem statement. Okay, so we wanted to have a cheap and easy way to do it. The application code is there. We just need to find a way to be able to host it in the cloud. Okay, think about the hosting solution, think about the database solution, as well as things like, of course, that open source solution didn't have a Docker file built in, so we had to think about how to containerize it because we wanted to use some serverless solutions. Okay, and I'll cut to the chase to give you the final architectural diagram. Essentially, we use one of the tools that Harizwan demonstrated just now, which is building our own Docker image and then deploying that to Cloud Run as a serverless solution. Okay, and of course, there's secrets in this this Cloud Run application as well. So given that we are running this with integration with the database, so you have some sort of like database password that you need to use to access the database. So definitely we need to go back to use something like Secret Manager over again. Okay, and similarly, if you're using Docker images, you can either use container registry or you can use artifact registry. So over here, that's used for your image repository to store your Docker images. And this is essentially something that, if you're looking at this hackathon to build a web application, you can use a simple setup like this, replicate it to host your own solutions. All right. So we were able to succeed doing that. You can see over here, this is the same interface that Harizwan showed just now. This is the Cloud Run application that's running. And then, of course, when we run, we go to the site itself, you'll see that this is the application that's currently live right now. Okay. And of course, I just want to give a little bit of a breakdown into the cost, the time cost into this, just to show you how easy it is. The entire time, when I was told about this idea, it was on Friday night. And when I was done with it, it was actually almost midnight on Saturday, going to Sunday. And most of the time, I actually spent on understanding that open source code and understanding how I could Dockerize it, fix minor bugs in the system. The actual deployment was actually quite fast. And given that this was, I think like for Cloud SQL, that was something that I haven't touched in a while, even with that, I was able to quickly jump in and get into deploying this application very quickly, from a simple Docker image all the way to a production application, like a live page running by 12 midnight. So 9 p.m. to 12 midnight. So if you're running this in Hackathon, definitely the cloud portion, it might be a bit daunting, but don't be afraid by it. Most of the documentation out there would teach you on how to get on very, very quickly. Okay, and also just to show very quickly on the cost itself, actually a big part of the cost goes to Cloud SQL. The rest of the costing, I've been running this for 3.5 days, or actually close to 4 days now. It's actually not very costly. One other thing is that I actually unchecked the discounts and the promotions tab. So if you have credits that are already assigned to you, that you can use to offset the cost, in fact, you might not even be paying a single cent for running an application. And of course, like for this one, right, just to mention, I'm running it 24 hours. So I'm paying for this. If you want, of course, you can switch off your application if you're not using it, just to lower the cost. Nagging about this, in fact, I'll nag about this again in this screen, which is take note of your free quotas. As a student, I think somewhere in the year of 2012 to 2013 period, I used Google Cloud to host my own personal website of around 4 to 5 years using App Engine. And truth be told, I didn't pay a single cent. And back then, I was a student. I wasn't even a GD at that point. So I didn't pay a single cent because for App Engine, they had free 25 hours back then for the smallest instance. And you can just run that 24 hours and then a second instance for 1 more hour. All right. So I would definitely very much encourage you, even if you're a student right now, you can actually explore the free tier of Google Cloud. See what tools you can use to run solutions that you need, especially if you are looking at building your portfolio. Why not use it to build your own personal site and host it in Google Cloud? It's free anyway, especially if you go for the lowest tier, and you can use that to build up a profile and portfolio for yourself really quickly. I think that's one of the ideas I usually tell some of my juniors as well as my colleagues at work. Okay, so I have reached the end of the sharing. Hopefully that wasn't too much knowledge. Again, ask me any questions if you have. Reach out to me here if you want to. So, yep, that's all.
Thank you so much, Mr. Varyan, for the truly riveting sharing on the case studies with Google Cloud. So we shall move on to the question and answers for both of our speakers. So.
Hi, I'm Singhan, and I'll be handling the Q&A section. If you guys have any questions, please feel free to place it in the live chat. So we have one question from our participants. Why is a certificate so important for a cloud engineer? What about those who are self-taught and may not have the cost of getting a certificate, or maybe don't have enough time?
Lian, you want to take this up first?
Okay, I'm going to paste like a link so the funny thing is I actually chanced on this link like a week ago when I was writing a blog post. I don't know if y'all can share that in the, in YouTube channel. But that's the official Google Cloud answer is why you should go for a certification. But that's it. It's not a mandatory thing. I think like for myself, I currently don't actually have a cloud certification, though I am intending to go for that later this year. And if anything, right, the certification I'm going for, right, it's something I haven't done in the past yet. Like I did have a certification a year ago that I let it lapse. But the certification I'm getting later this year is actually more of a self-validation, making sure that I understand what's being covered right now in Google Cloud. But that's it. I'm doing quite fine without certification right now. I mean, you can self-study to get your knowledge in. You don't exactly have to go for certification, but it's encouraged. I mean, in the link I shared. Yeah. What do you think, Harizan?
I'm going to take a more controversial stance. So basically, when it comes to like hearing who tells you to get certification, you will see that it will be the cloud provider themselves. Like, Google will tell you, you should take certifications for Google Cloud, right? And then AWS will also do the same. But it all boils down to your career and your career choices. At the end of the day, it kind of like it depends on how you learn. Let's say you need some sort of guided way to kind of learn stuff. Doing certifications do help. Like you are at the end of the day tested on a certain set of knowledge. It is helpful for the initial set of your career, but as time goes, it gets less and less useful because there's only so much you will get tested in a certification exam. All the little things that are actually more important, the nuances, those come with, like, unfortunately, it comes with experience. So I'm going to say that, like, it's useful only at the beginning part of your career. As time goes on, it's not as useful anymore. But the thing is, you can still, it's still possible to get yourself launched into a career without it. The thing is, one way is, I think Wei Yan mentioned just now, is you have some sort of portfolio projects. He did mention that he worked with his professor on certain, maybe it's possible for you to, like, work on certain things, put it on GitHub repo and say, like, let's say someone asks, you can show them, okay, I did this, then you can take them through when the interviewer asks about the project details, you can take them through what you did and were there any issues that you went through and how you overcome them. Yeah, the certification at the end of the day is just a sign that you know something. People will generally in the end find out whether you really know it or not.
Okay, thank you for the answers. And we have another questions. What are the requisites to enter into cloud domain and where could one start?
Okay, I guess I'll start first. So cloud domain, so this, so the truth to be told, right, it's only like last year or 2 years ago when I started seeing roles for this thing called cloud engineer. Before that, there was no such thing as cloud engineer, or like it's very rare. So that thing about cloud engineers is, right now I don't know what they actually do, because the cloud platform itself, like, you actually need a full-on resource or a full-on person to actually take care of it. It is a very, very complicated field. I think Wei Yan also show, like, if you do it manually, you probably might die doing it. It's actually, you have to understand a lot of the concepts, the permission systems. And let's say if right now, I think a couple of companies out there, they are doing this, like, multi-cloud strategy. So if you're a cloud engineer, you not only have to learn one cloud, you have to learn multiple clouds and find out how they work synergistically with each other. So yeah, like, the requisites per se, as of now, like, if you want to quickly get started, there isn't just jump in, just go with a cloud platform, just start trying things out. There, basically, when you go for the interviews, when they ask you for this cloud engineer role, basically they want to find out how much have you hurt yourself in learning concepts of this cloud platform or the different cloud platforms. Yeah.
Okay.
I can add on to that. In saying that, I think similarly to what Harizan mentioned, experience of using the cloud platforms, be it GCP or the other competitors, generally would help. I think a lot of these tools across providers do parallel each other. But I think beyond that, okay, so similar to Harizan, I think, yeah, this is very much a new role, and I don't think I've actually hired someone as a cloud engineer yet, maybe more so as DevOps, if anything. But given that, I would actually say, being the requisites itself, probably you need to look more into the area of DevOps, understanding things like the 5 pillars of DevOps, reading up, especially, like, a few books I would recommend is the SRE handbook. And then another thing is the Phoenix project, though that one, it's not really so much of a fully DevOps book, but it's still a pretty good read for fictional book, actually, I would say. Yeah, I think, and of course, just now we talked about the Google Cloud certification, right? So I guess this is where it actually came back, in the sense of, like, yes, it's not needed, but it's still a good bonus. Like, if you're comparing against yourself and some other person, if you have a certification, it's always a bonus, especially if it's the tool that the company is using. Like, if the company is using Google Cloud, if you have a cloud certification from Google Cloud, that is essentially a bonus for you already.
Yeah, okay. So we have another questions. How does cloud engineers differ from DevOps, sysadmin, or engineer?
Maybe I'll go first, but I think my answer is actually super short here because I like I said, I think earlier on, similar with Harizwan, I think this is also some new role that I'm not exactly sure like what it entails. I like to think that it's probably closer to DevOps, or maybe in some areas. In the end, I think it depends on the companies as well. Like some companies call them DevOps, some companies call them sysadmins. Then there are some backend roles that might also overlap a little bit with DevOps. So in the end, the interpretations seems to be going back into the company. And of course, when you're applying for the role, they will tell you what exactly this role entails and what you actually need to know. That's it. I would think that definitely it would overlap more with DevOps. Yeah.
Okay.
Yeah, I'll probably add on to the answer a little bit because I was like someone sent me a link to a cloud engineer role and they were asking some details about it, and I saw an interesting point. So DevOps engineers they generally do how applications get to production and everything. But there's an interesting addition for cloud engineer where there was this point where it mentions that as and when needed, the cloud engineer will probably need to contact Google Cloud Support or AWS Support and ask, and if they have like specific requirement, like need to work with these support teams to kind of get the things that they need for the company. So I guess there's a kind of a need for soft skills there, because when this kind of like hefty application requirements come in, there will be a lot of pushback and then basically kind of need to negotiate for a good deal for your company. So maybe there's one main difference. Maybe I don't know, but yeah.
And here's another question. What is your point of view for the security aspects in cloud? What are the career path that the entry-level cybersecurity engineers can get started with? So,
Can you repeat the question again? Like there are two parts, right?
so first one is, what is your point of view for the security aspects in cloud? What are the career path that the entry-level cybersecurity engineers can start with?
Okay. So security is a bit more of a touchy subject, and also not super qualified to talk too much about it. I mean, one thing for sure is security is kind of the most important. Like when it comes to web application, it's like if your security is weak, your application might as well you would just shut it down essentially. Because any security issues that come up with your application, you will be beaten hard. Someone like if someone like kind of want to find fault with your company and like and if the application happens to be the weak link, someone will find it and they will exploit it. Whether you find out that you are exploited is a different story. I can tell you one story that happened. So in terms of security aspects in cloud, so I once needed to deploy Redis. Redis is essentially a cache. I didn't know how to kind of deploy it properly. So what I did was I deployed it and exposed the interface to the whole public sphere. I think there's a Redis pod. Every week my Redis will get locked up, and I have no idea why. So essentially, I will deploy Redis. The application will work fine for 1 week, and then 1 week later, it turns out that the Redis instance will get locked up. Someone put a password in. So apparently, what I was reading online was there is scanners out there that attempt to prevent security incidents by purposely locking up Redis. So they're essentially saving you from being exploited. So this is kind of one thing, like you kind of need to be aware of these security things. But then the thing is, at the end of the day, basically you have to read up a lot, and basically you have to rely on experienced personnel who have been burned before by security incidents. to tell you like you should do this or you shouldn't do this. Like, let's say course, there was an incident, certain companies will come to course, this cross-origin resource sharing, I think that's to do with the browser. There was a company that didn't configure it correctly, and because of that, it resulted in a security incident. If I remember it, I'll put it on the YouTube video. But yeah, so security incidents it's kind of hard. Yeah.
Okay. So
Suppose I, oh,
Yeah.
suppose I can add maybe just a little bit, because again, I think I'm not a security engineer as well, but I can talk about it from my perspective of in the workplace. And if you're asking about, okay, maybe I'll answer it a little bit about from the career prospects of security in the cloud itself, in that I think when looking at the cloud itself, it's not exactly just referring to one single, like let's say for Google Cloud or any of the other cloud providers, like being specialized in that, but rather having the generic knowledge across the board in terms of hosting applications or cloud solutions in general. And there's always a need for that, given that, let's say, like if I'm doing a B2B business, and usually you have to, or if you're going for government projects, there's always tenders, you always have to write some proposals. And something that comes along with all of this, right, is usually compliance and a lot of paperwork that comes along with what practices that you're doing in a company. And usually the security aspect of the company itself, or those security engineers, would come in for those portions. And even if you're not B2B, right, you're B2C, right, that's still important because of recent things that comes up, like over this past few years, like GDPR in the EU region, or CCPA in California, I believe. All this data privacy related laws are all linked up, as part of the concerns of consumers, as well as going back into data leaks and all these issues happening here and there. And there's definitely that increased reliance or a call for companies to be able to secure their applications better, follow whatever ISO standards or policies they need to get in order to qualify for certain, let's say in the business deal, be able to get the ISO policy in order to qualify to get that business deal signed. Yeah.
Okay.
It's important. Yeah.
Okay. Thank you for answering the questions. And I think there's no questions from our participants. So if there's no questions anymore, I'll pass it back to Alina.
Okay, so with this, we have come to the end of our second workshop, Bootcamp. So do tune in on May 14th, 12 p.m. for another knowledge sharing session on Firebase. See you guys there. Also, I would like to thank our speakers for taking time out of the busy schedule and sharing their valuable insights on Google Cloud. I'm certain that a student audience have learned a lot today. So this is a reminder for all participants to join the Discord channel if they haven't already done so, and go through the starter kit for any other information pertaining to the event. For hackers, we hope you have started the ideation process for your hacks. The submission for the same is on May 16, 3 p.m. SGT. So thank you so much for everyone who tuned.